All right, let's start off by having a look at the Picoscope triggering and the Picoscope probe. So the first slide here is we'll look at the Picoscope probe, and you want to make sure that on your probe tip, okay, you have this set to times 10. The purpose of setting it to times 10 is to ensure that the loading that's added when you connect your scope probe to the circuit is minimized. That's called the attenuation. So the attenuation of the times 10 enables the impedance to be very, very high on the circuit, so it doesn't load it. So make sure that's always set to times 10 right here. Okay, and when it is set to times 10, you'll see this little message on the screen of the probe. And most of the time for TTL signals, I like to use plus and minus 10 volts. Okay, secondly, it's triggering. And there are different modes of triggering. You see them here. I think in the older version they called it normal, and the newer version they seem to call it repeat, and they're actually the same thing. But you have none, no triggering, single triggering, auto, and repeat. We will not be using ETS. So use none whenever you want to measure DC signals, some signals that don't pulse, or an unknown repetitive or pulsing signal, for either one of those two conditions. Whenever you have a repetitive signal, like a square wave, use auto. Okay, that's the simplest and best method when you're triggering the scope for something that's repetitive. If it's not repetitive, you may want to use either repeat or normal or single, either one of those. So repeat and normal will trigger, stop, and wait for a second trigger, but it automatically will re-trigger. Compared to single, it will trigger when it receives the trigger event, but then it will stop and you'll have to press capture again or over and over again. So here's another summary of all those things. So you want to select mode, and we're normally going to use simple edge. Source is the channel that we're going to trigger from. A is the blue channel in this case. B is the red channel. And the pre-trigger position is just where that trigger happens horizontally across the screen. Is it near the left-hand side, the 10 or 20%, or is it over on the right? The trigger threshold level is the vertical voltage level at which we're going to trigger. For TTL levels, 2 to 3 volts is a good setting. And the direction kind of depends on what you're trying to measure. Typically, if you're measuring the high time, you want to select rising. If you want to measure the low time, possibly with cursors, you'd select the falling. That's called trigger. So remember that none is quite often used when you don't know what the trigger signal will look like. Auto is probably the most common, and single or normal or repetitive are used when you have signals that don't repeat often. So it can be used, for example, looking at switch bouncing. Single is very good for that. Hello, this is an example of running the Picoscope to measure the signal on pin 45 of the Arduino. This is a repetitive signal. It just continues to repeat over and over again. So let's point out a few things. First of all, one of the things you have to do is to set up the scope probes and the vertical settings. So I've got the vertical set to plus and minus 10. That means at the top of the scope screen, that's positive 10 volts, and at the bottom, that's minus 10. And since the scope has 10 divisions, that means that there's 20 volts divided by 10, which will give you 2 volts per division. And you see that here. This is 0 volts, 2 volts, and 4 volts. So you can change this, but 10 volts is a good setting for TTL levels. The next thing you will have to set up is the probes. And we always want to use standard probes that are times 10. And you have to make sure that the switch on the physical or actual probe is set to times 10. The setting in the software and the setting in the probes has to match, or you won't get the correct readings. Once you've done that, the next thing you want to do is go to triggers. I'm going to set up triggers. And for this type of repetitive signal, the most common trigger mode is auto trigger. You can see these little bumps here are indicating that it's triggering all the time. The yellow triangle is the trigger edge, and I've got this scope set up to trigger on channel A, okay, and A is the blue trace, to pre-trigger at 10%. So this first vertical line is 10, the second is 20, 30, and so on. So if I switch this by clicking plus, now it's triggered on 20%, and that's where the timing starts. I tend to set it up at 10 or 20% because I mostly want to look at what's to the right of the signal. So 10 or 20% will work. And the next is the threshold. This is very important. The threshold is that yellow diamond that you see here. And for TTL levels, you want it to be somewheres in the middle. So 2 to 3 volts is a good setting. So I've set it here to either 2 volts or 3 volts, and it triggers because the incoming repetitive signal sees that rising edge. Now, the last one is the direction. It can be rising edge or falling edge, and it depends on what you're trying to measure. So if I set it for falling edge, it quickly allows me to see that I have a time of about I'd say that's 1 millisecond. This is 2, so maybe 1.6 milliseconds. And we can come down here to our measurements and just see if that makes sense. Well, I don't have the time low, but I do have the time high pulse, and it's 0.4 milliseconds. So that must mean the low time is 1.6. Now I can trigger on a rising edge. Let's try that. So down here. And notice that it seems to be about 0.4 milliseconds, and that's the high pulse width. So this is the high pulse, this part is the low pulse. From this rising edge to the next rising edge is the period. The frequency is 1 over the period. Period and cycle time are the same thing in this case. If we want to make some measurements, the place you would go to is this icon here that says measurements. And these are all the possible measurements. And there's measurements for channel A or B, different amplitude measurements, so vertical, and different time or horizontal measurements. And I've indicated the more common ones, the cycle time, which is an automatic measurement, positive duty cycle, so the time high, the duty cycle for the positive signal. This is the high positive. So you can see here that the period's 2 milliseconds and the high time is 0.4. So 0.4 divided by 2 gives me the 20%. Okay, the frequency is 1 over the 2 milliseconds, or about 500 hertz. So to choose those, you select either frequency, cycle time, positive duty cycle, and so on. So these are the places that you will have that. You can also add notes. So in this case, I have Lab 5, Part 3, but if you print this, I don't think it displays both at the same time. I tend to use small versus medium or large, just because small seems to give you the most information in the tightest space. I can also make measurements with a cursor, and to do that, the cursors normally sit up in this top left for the vertical measurements and at the bottom left for the horizontal measurements. So let's say I wanted to measure the difference between that top peak and this bottom peak. Well, it tells me the difference is the number 2 cursor is at 0, the number 1 cursor is at about 4.8, and this is the difference, or the delta between the two. If I want to get them out of the way, I just close this window. I can do the same thing for time. Line it up on this first vertical line. Okay, and then the second one, line it up here. And the difference in time between those two is 394 microseconds, which is very close to what we expected. Or I can measure the period from rising edge to rising edge. The period of the signal is 2 milliseconds. And if I want to remove those cursors, I just click that, and it brings them back to their home position. The time-based setting is up here, and right now it's set to 1 millisecond per division. And you'll see that if I make it 1 microsecond, that's too short. And if I make it 1 second, I'm just going to have too many waveforms. So you want to pick a value that will give you somewhere between maybe 2 to 5 periods on the screen. So let's see, 10 is too many, 5 is still too many, 2 is probably too many. We're getting close. So 500 or 1 millisecond will probably work. 100 is not enough because we only have one trace. So I'd say 1 millisecond is a good setting for that time base. Okay, and I think we looked at trigger. Yeah, we went over all of the triggers. So this yellow icon is indicating that we're triggered out of that particular position. If I set it up for single, okay, you'll notice that as soon as it triggered and displayed a trace, then it stopped. If I wanted to capture again, I have to press start and it stops. You know that it stopped because you see in the top here, there's no more noise that you see, whereas in auto mode, and you click run again, you see that noise. So it's showing you that it's continuously updating the information. If I have it set to no trigger, well, it's not going to trigger anywhere, but this can be very useful to see if you are getting any kind of a signal. So if you have something unknown or it's a DC signal, that's a great way to display it. For example, I'm just going to take my wire off of that signal and I can easily measure my 5-volt signal and my ground signal, and doesn't need a trigger. So now we're back in that signal, we're back on auto, and repeat is very much like single, but it just automatically re-triggers. So I don't have to press that start button to re-trigger again. Right now, most of the time when we're measuring signals like this, we want to have a simple edge. But you may recall that when we were doing I2C and SPI, we used pulse width. But there are many other types of signals, but I won't go over at this point in time. So auto is a good setting for any kind of repetitive signal like we see here. Thank you. This second information is on using the Picoscope to measure the Quadrature encoder. So to best do that, probably the time base should either be set to 50 milliseconds or 20 or maybe even 10. But 10 to 50 milliseconds is a great setting for that. You also want to make sure that the scope is set for plus and minus 10 volts, which it is. So that means that the 20 volts difference divided by 10 is 2 volts per centimeter. And here I want to make sure that I've set the vertical. It's manually set, which I find is the best way if you know ahead of time what it will be. The probes must be standard probe set to times 10. And you also have to make sure that the switch on the probes is actually set to the times 10 position. That's important. And setting it to times 10 means that it will have the least loading on the circuit that you're connected to. Okay, so that's very, very useful. Here I only have one trace and I have the encoder connected and it's set up for repeat. So repeat is very much like single, and I'll show you single. So if we come here and I set it to single, well, let's try none first just to see the differences here. So none is displaying something all the time. There's no trigger. You don't see that yellow triangle. And when I move my dial, you can see some traces, but they go away and they're not triggered. I lose it. So auto will do something very much the same, but you see the trigger icon, that diamond shape. And when I turn this dial, it triggers, but after about a second, it goes away. Okay, it triggers, so it forces the trigger, but then it goes away. So that's not a great mode. And as I said, single will give it to me. It freezes, but then to repeat it, which this may be okay, I have to click this button again. Okay, and it freezes it. And then if I move this dial again, it's going to give me a different trace, but then it stops. Whereas repeat, and I have to click the button again, will give me a trace and it stays there frozen. If I move it again, it's different. Move it again, it's different. So it's kind of like doing single, except that it's automatically hitting the run button. So I can change that dial, change it again, do it very fast, do it very slow, and it's always showing me an update to my measurement. The next thing you will want to do is, since the encoder actually uses 2 channels, I want to turn on the second trace. So I have to set it to manual, make it plus and minus 10. Make sure my probes are set to standard times 10. They are. It shows you that in this area here, and it shows you that. The other thing to be aware of is channel A is blue, channel B is red. And so I'm going to set this up for no triggering, so I can just see my traces. So if I move the knob on the encoder, you can see that. And you want to have the traces separated. Don't overlap. In general, you don't want to overlap. The other thing that's very important is if you want to move that trace line up or down, you're going to grab onto it in this blue area over here on the left-hand side. And I'm going to move it up, and I want to have it so it's triggered, or sorry, that it's set up on a line where it's measuring 0 volts right on a line. And same thing down here, it's on a line, and I'm only going to go from 0 to 5 volts on the B channel and 0 to 5 volts on the A channel. So I have enough space to see that information. All right, I'm going to turn the encoder dial. And you can see I'm turning it clockwise, counterclockwise. Wherever there's a gap, it means that I'm not turning it. If you see more pulses, that means I'm turning it very quickly. Or if I turn it slowly, this is what you get. Okay, but it goes away in none. So I'm going to actually use single. And I'm going to turn it. And it triggered. You can see that it triggered up at the top. And I can actually count the time between pulses to see how many pulses I received per revolution. So it stopped. If I want to start it again, I have to click on that button. And it's running, but it's actually the old data, so I'm going to move it one more time and it captures it again. So I like to use repetitive for this. So I'm going to go to trigger and do repeat. I have to get it running, but every time I turn it now, I'm getting a new acquisition. And I'll try to do a smooth turn here. Okay, and what I want you to notice here is that all of these turns that I'm making, they're clockwise. They're clockwise. So on the positive edge of this top signal, which is the clock, every time the clock goes through a positive transition, let me put a cursor here. So I put a cursor on that positive edge. You see that the data underneath is a high. Next positive edge, data is a high. Positive edge, data is a high. And all the way through, every positive edge, the data is a high. Now the width is dependent on how quickly I'm turning the dial. That's why sometimes it's wider, sometimes it's narrow, but it's still recording or capturing the time high every time I have a positive transition. But now I'm going to turn it counterclockwise. Okay, I just turned it counterclockwise, and notice now every time I have a positive edge, so here's a positive edge in my clock, and I have a low below that. Positive edge, low, positive edge, low. Okay, and the term quadrature comes from that if you look at one period of the signal from here over to here, there are 4 different edges. So a rising edge on the top trace, rising edge in the bottom, falling edge in the top, falling edge in the bottom, and then it repeats again. So quadrature is an indication that there are 4 different edges that occur. So let's move this back and forth. I'm going to try to get an even one here. So that one's fairly even. So by examining the measurements I've just made, it took about 50 milliseconds for one pulse. But this rotary encoder produces 20 pulses per revolution, or about 18 degrees per pulse, 360 degrees for those 20 pulses. So if I take 20 of these pulses and multiply it by the time per pulse, so 20 times 52 milliseconds, that gives me about 1,000 milliseconds, which is 1 second. So that tells me that I was turning this dial at 20 pulses per second, which is about 50 milliseconds. Now let's just look at the different settings for trigger mode. So none, it's triggering all the time. Well, it's displaying data all the time. You'll see that in none, there is no little yellow icon. And when I turn this dial, I'm always going to get something on the screen. It doesn't stay there because when I stop turning, I'm stopping producing the pulses. So that's none. This is auto. So in auto, you can see there is a trigger on channel A. And when I turn the dial, it triggers. But after a period of time, that goes away. And it's showing me that right now, that top line is high and the bottom is low. I'm just going to move it here. And you can see right now they're both low. They're both low. I don't know if I can get it high. Maybe if I move it halfway. Yeah, the top one is high now and the bottom one is low. So they'll change as you turn that dial. But it's always waiting for a trigger, and when it receives it, it'll force it to appear on the screen. Repeat, or actually let me do single first. So single, there is a trigger. Okay, it's running. It doesn't see any triggers right now until I turn the device. Then it sees a trigger. Triggers, fills up the screen like you see here, and then stop will appear until you press start again. And actually that's the old data. I don't know if I can clear that. No, it'll keep the old data there, but if I turn the dial again, you'll see new data. And even if I turn it again, nothing will change until I press run. And then every time I press run, it'll update or it'll update and then stop. Now, if you wanted to go automatically repetitive, what I would choose is repeat. Okay, and you have to hit run. But now it'll automatically, it kind of automatically in the background is pressing that button for us automatically after a period of time. So there's a trigger. I move my dial. There's another trigger. I move my dial, another trigger, and so on. So repeat is a good position to use for this encoder dial because it's always updating. So if I go really slow, you can see the pulses are separated. And right now the rising edge gives me a logic high. If I go the other way, rising edge gives me a low. This is clockwise, that's counterclockwise. So I'm able to see what's happening in the background. Thank you.